But in order for me to set it up, and please, everybody, I beg you, just forgive me what I'm going to do tonight. It's seriously boring, but I would like everybody to do it with me. Just before class, about 15, 20 minutes ago, I put in a file, an Excel file in Blackboard, and I made it to activate at 6 o'clock, 6 p.m. Okay, so if you go there, you'll see an Excel file with 2 columns. The first column is time. The second one is returns to a particular stock. And I like for you and I to work with this file tonight, okay? I like for you to do a number of things on Excel, because Excel will be faster for us to work with, and then you can save the Excel file, and then we shall continue on Thursday. Okay, has anybody seen the file? Did anybody go to my Blackboard site?
Yes,
Yes.
sir.
Okay.
Yeah,
Excellent.
These are yearly returns, Professor, right?
Yes, it's yearly returns, only 1 column. So I'm going to show you first. I'm going to show you what I need all of us to do. I'll show you maybe a couple of them, and then I'll just keep quiet, and you all will keep doing the rest. And when you finish the exercise, I'm going to ask you to plot the graph, everything tonight. I want to make sure, if you don't want to do it, don't worry about it, don't do it. But it would be nice for you to do it so that when I eventually define stationarity, it will make a little bit of sense to you and I, okay? All right. So any questions from last class, last week, anything at all? All right.
Professor?
Alec?
So, yeah, maybe I'm going too ahead, but I want to know something about the reading. Some of the formulas, especially the ones about statistics.
Yeah, nasty, right?
Yeah, they were kind of, they were like this in the previous book that I had on econometrics. And I was wondering, like, how important will they be in our class if you will have a chance to simplify them for us or explain some of it. Yeah, that's my question.
I will, definitely.
Okay, thank you.
Okay. And anything I do not want you to know, I will not bother you with it. But I want you to just keep reading chapter 1. Yes, the formulas are nasty, but read them first time. Don't worry about the formulas, even though there are many formulas everywhere. Just read the words, understand as much as you can, and then later go back again. So this Thursday, I will do a little bit more. I'll give you some R exercises to do following the book. So just walk with me, okay? I know what I'm doing, because many times, many of you come out of Echo 4000, and yeah, you can do some practical things, you can run regressions, but there are some details that you miss or you didn't catch up on, which is okay, because they are throwing a lot of things at you in Echo 4000. So in this class, we're not going to do too many chapters. We're going to do maybe 4 or 5 chapters, but each chapter is very dense, full of formulas, full of information, okay? But in the chapters, I will guide us, you and I will learn what I want us to learn, and then move on to other chapters. But I'll take it easy, because we don't have too many chapters. And then I'm going to assign some class projects to do, some team projects. So the learning will be slow, steady, but I want you to keep up with me. And some of them can be really tedious and annoying, but useful, okay? So like tonight, what I'm going to do tonight, some of you will say, why is he making us do this? But just bear with me, just get it done as much as you can, so that when in the future we begin to talk about other concepts, I will say, do you remember what we did in class? That's what I'm referring to, okay? So Alec, thank you for that question. Chapter 1 is very dense, especially if you are not used to theoretical, not theoretical really, the notation in the book. But that's okay. I'll talk about all of this in English as we go on. Okay, good. Very nice. Okay, so so this Excel file we're going to use it to do some work tonight. And again, I'm going to ask you to do things. Some of you can do it a lot faster than me. So go ahead and do it. I will record it in a minute, Joseph. Okay, so go ahead and do it faster than me. But I'll tell you what to do, and then I will get it done. Okay. Thank you, Joseph. I was just about to begin to record. So I'm going to record now.
This meeting is being recorded.
Professor, where are you putting the recordings on Blackboard?
Under video. Did anybody check? Under course documents.
They're there.
Yeah, they're there. I saw them, I believe yesterday, or maybe even today.
Yeah. I've been putting them in. I think I put them. Somebody reminded me to put them last week, so I think I put them in on Thursday night or Friday, early Friday morning. So I think you have all the classes there now. Okay. If you don't, just pick up, please. Let me know. Thank you. So it's being recorded. Very nice. So everybody, let's go to, so let me share this document. I'm going to share an Excel file, the same one you already have. And it's going to be quite funny what you and what you and I are going to do. Oh my goodness, it's going to be quite funny. Okay, so so we have, so for now, let's forget the year. We're not going to be using the year, but the year column is quite important because the year column is quite important because it will give us the time index. That's what makes it a time series. Okay, so the first thing I want everybody to do, just watch me now. I'll do it slowly, but you can do it much faster than I can. Just watch me. So I am going to take this x of t. So x of t is returns, right? Wait, what's going on? Okay, so I'm going to highlight x of t, right? All of x of t, and I'm going to copy into another column. So I'm going to copy x of t here, and I'll paste. And I'll put x of t right next to it, and I paste. So I have two x of t's side by side. And then I'm going to give 1, 2, 3 spaces, and I'm going to put another x of t, okay? And I'm going to do another 1, 2, 3. Maybe in the fourth one, I put another x of t. All right, and I'm going to do 1, 2, 3. In the fourth one, I put another x of t. Fantastic. So that's what I'm going to do. I'm going to just copy x of t, but in this first one, I put x of t next to x of t. And here, I'm going to type something called x of t minus 1. Okay? And then right next door here, I'll put x of t minus 2. And if you know how to write it as a subscript, go ahead and do it, but no need. And then right next door, I'm going to put x of t minus 3. Okay? And then each one of you later, between now and Thursday, I would ask you to do it up to x minus 12. Okay? So x of t, x of t, x of t, x of t minus 1, x of t minus 2, x of t minus 3, up until 12. It's crazy work, I know, but please. And do it when you are happy. Okay. So what do I want to do with this x of t and x of t next to each other? All right, voila. I'm going to go all the way down. I'm going to go all the way down to this x of t and x of t next to each other. And I'm going to show us what we already know. So at the bottom of it, at the bottom here, I am going to calculate the mean of s of t, x of t at the bottom here. I'm going to calculate the variance of this x of t. Same column, the first one, this one. So I'm going to say, I'm going to type here mean. And then I'm going to type here the variance. Okay. All right. So the mean here, I am going to say equals. I draw down my formula. Is this too fast? I mean, you guys, you know how to do this, so I won't even bother. So I want to do the average. So I select the average. I say, okay. Now I'm going to define the range. So I'm going to pick up this range from D4. I hope as many of you are doing this with me. Yes, it is very simple and annoying, but if you are in the mood, please do it for me. Then I'm going to say yes. So the average is 12.64. The average return from what was it? From 19, what was the beginning of the time? 19 what?
37.
So this, call it IBM or call it Uber, not Uber, call it IBM. On average, from between 1937 and 2007 gave on average 12.67% return. And by the way, these returns are holding period returns. They have dividends, stock splits, everything already accounted for. How about the variance? So let's go ahead and do the variance. So I do equal to, and in this case, please, let's do statistical. So I'm choosing statistical because I want to select a particular variance. I want to select the variance of the population, not sample. And there's a reason why, okay? So I'll select the variance of the P, VARP, variance of the population. Okay, guys, so I'm going to select it. So I say, okay. And it will be from B5. So I say, okay. Okay. And what's my data range?
D4, D74.
Thank you. It's okay. I like to select it myself, so I know I'm being useful. So D4 to D74. Thank you. You see how inefficiently I do things? So, bingo. What did I do?
You have to get rid of the N. You have something before the D4 plus D74.
Oh, I had something. Okay, sorry.
The N83.
Huh?
I think, no, it's fine. Just reset.
Okay, okay. So let me just do it again, right? Okay. VRP, it's okay. Let me check it. So I'm giving all of you slow pokes. I'm giving all of you time to catch up with me. I don't think anybody in this class is slower than me. Oh, right, N90, thank you so much. So I do, okay. No. God. What am I doing wrong? Okay, D4, I'll just type it, D4. Colon, right?
Yeah.
Colon D, what, 74?
Yeah.
Yes.
Variance is 406.94% squared. All right. So we're going to do only the mean and variance, the first two moments. All right. But later at home, between now and Thursday, I'll ask all of you to do just for this XT, just for this column alone, do the mean, the variance, the skewness, and the kurtosis, but not now. So when you get home, put here the skewness and then put here the kurtosis. That's all. All right, but don't do it now. But now I want to go now here, and I'll give a little space in between. And I want to do the covariance between XT and XT. You got it?
Isn't that supposed to be 1?
Okay, let's see. Let's find out. Okay, so now because I want to do it this way, I would suggest for you all to do what I'm doing. Remember how you run regressions in Echo 4000? I want to use data and data analysis. Do you remember that? Do you guys remember that?
Yeah.
Yes.
Okay. And if you do not have data analysis, here on the extreme right hand, top right hand for me, if you don't have it, then you need to go bring it. It's already in your Excel. You need to go bring it into Excel, okay? All right, so I do data analysis. Wait, why the heck is this not working? All right, somebody is messing me up here. Okay, let me go back to home. Let me do data. Why is this not working?
Are you clicking? I think you have to click on data on the words. I think you're just clicking below it.
I'm clicking below it.
Yeah.
Thank you.
Mm-hmm.
It's okay. Thank you so much. Thank you very much for that. All right, so now let's do the covariance. Okay. Remember when you were doing Echo 4000, when you do the data analysis, then you scroll down here to regression. Yes, you remember that? So it's the same screen, but let's go to covariance and let's do okay. So I want to do covariance between XT and itself and XT. So what is the input range? I'm going to select the input range from D4. I'm going to use, I want to include the heading, the labels on the title. So it's going to be D3 to E74, okay? So D3 colon E74. All right, actually, let me just make sure, because when I do these things, I run into big trouble. So I'm going to select myself so I can view what I'm doing. So I'm going to here, so I do here, and I go here, and I select everything. So I'm doing the covariance between XT and itself. All right, so that's what I'm doing. And then look, everybody, because I selected the labels, the titles, I'm going to check here to tell it that I have the titles. Then I'm going to ask for the input range. Then I'm going to say here, all right? Then I'm going to click the range underneath. So I want to put it specifically here. So that would be B80. All right? What happened? Did I do anything wrong? Nope. So B80, all right, so let me say this. Do you notice anything, anybody? Do you notice anything?
It's the same as the variance.
Exactly. So the covariance between IBM's return and IBM's return is the covariance between IBM and IBM is equal to the variance of IBM. You got it? All right. Now, let me go one step further below. So below here, I'm going to do the correlation. Remember, the correlation is equal to covariance divided by standard deviation times standard deviation. Standard deviation times standard deviation is equal to variance. So covariance of IBM with IBM is also equal to variance. So I'm dividing variance by variance, so the answer must be equal to +1. Excel more, let's check. Okay, so here instead of covariance, I select correlation and I say okay. And I define what range. I select the range. So the range will be the same, D3. So it will be D3 to E74. Okay. I check for labels. I check the output. I click the output here, and I tell the computer where to put my output. And if you guys notice, your answer, I say here, your intuition was correct because all the correlations will be 1, 1, 1. So the correlation between xt and itself is +1. So far, so good, everybody? Okay, so I am going to do it for the next column. So everybody watch me what I'm going to do right now, okay? So right now I already created a column here called xt. So I want to create xt with xt lagged 1 period. All right? So here I am going to select this one, okay? So how do you say? So period, the previous period. I'm going to assume. All right, so what I'm going to do now is, I think my time periods are not okay, but you can think of the time as being reversed, and I'm lagging 1 period behind, okay? So in other words, I want to go here, and I want to select everything here up to here as the lagged one period lagged. Okay, so I may have to reverse my first column of time, but let's not worry about that for now. So, and then I'm going to copy, and I'm going to come in here, okay, under xt minus 1, and I'm going to put it in, and I'm going to paste. So essentially what I want to do is, I want to take my xt, and I want to take the previous xt. So you can think of, suppose I reverse this, I reverse the time, and one is 2007, 2006, 2000, so I can do that. And then I select the previous period, okay? But I just didn't do that for this exercise, but you know what I'm talking about, right? So I'm just lagging 1 period. Do you understand?
Kind of.
I'm really not following fully in terms of what t-1 means. Are we kind of taking like this as like almost like the return as like the next period?
Yes, the period right next to it.
Okay.
Okay. So no,
The period not including the first year.
yes, because okay, so in 1938, right? This should be 1939. Sorry, I just screwed up. 1939. Okay, let me see if I can explain this. In year 2021, what was the year before that? It's 2020, right? So if I have return to Uber in 2021, and I have suppose the return to Uber in 2021 is 15%, and the return to Uber in 2020 is 12%. Then as of 2021, the return in T-1 is the one in 2020. That's what I mean. It's in previous year. I think what was confusing you is the year here, the way I have it. So it's a little confusing, but we can always reverse this. We can always make the years so that how do you say, from, wait, let's see. Let's see. I should have done the years the reverse, right?
So my question is why are we taking from 1937? Why aren't we taking from 2007?
Yeah.
Yes.
Do you know?
Exactly. We can do that.
It's basically the same thing.
Okay. All right. So let's go and take from 2007. How's that?
So it's basically the same thing. It's just on the other end of the data.
Yes.
Okay.
It's just on the other end of the data. That's all.
Okay.
Okay. And so it's my bad. I should have put 2007 at the beginning with the corresponding number and then work the way down. Okay. So for now, don't be confused by the year column. You can do it correctly at home, but let me take you through the exercise. Okay. Is that okay? All right.
All good. Thank you.
All right. Let's see. Somebody is talking to me. The first column looks more like T-1. Okay. Okay. So the first column, yes, Ian, thank you. So in other words, this one, you can say this one is T-1, right? And then this one is T. So if 1938 is T, then T-1 is this. I think the best way would be to just reverse the years. Okay, let's see. Hold on, let me just think about this and see if I can make it a little bit easier for everybody. Here, let me go down.
It's easier to visualize it as if you like scroll down, we're missing a point from 2007.
Yes.
In the T-1.
So what I really meant to do is, if you begin here 2007, and then T-1 is 2006, right? And then T-1 is 2005, and so on and so forth, right? You got it?
You mean T-2 and T-3?
So T-2, no, okay. So from here, T-1 is this one, right?
Right.
And then from here, T-1 is this one. Then from here, T-1 is this one. So each year I go the previous year is lag 1 year. That's what I mean.
Okay.
And then later, I'll say from here, T-2 is here. And from here, T-2 is here. And then from here, T-2 is here. So I'm just lagging 2 periods. Okay, so from 2020, T-2 will be 2018. Then from 2018, T-2 is 2016. So I'm going down the series, lagging 2, 2, 2, 2.
The T-1 on my point of view means that you're displaying for that specific year, let's say 2006, you're displaying the return of the previous year, or of T-1.
Yes, but yes, go ahead.
Then this is T+1. What you just did, because for 2006 you're displaying the return of the next year.
Exactly.
So maybe if you could reverse it.
Okay, so let me reverse. Instead of T-1, let me put it as T+1. Okay. All that concerns me is one lag period. I don't care whether it's minus or plus.
Well, Professor, you could just put 2007 at the top and then just drag it down.
Yes, but I want these numbers because these numbers are the real deal.
Okay.
These are the real numbers from Wall Street, okay? Okay? All right, so yes. So here, so thank you. Who made that suggestion? I think this is the best, I'll feel better this way. So I can say t plus 1. T, where the heck is plus 1? Okay? I just want lag 1 period, t plus 1. And then t plus 2 here, and then t plus 3 here, okay? Everybody got it? Okay. Because when we define stationarity, whether the lag is forward or behind, it won't matter to us. Okay, so so this is t plus 1. Now let's do t plus 2. Everyone, please just bear with me now. Look at me. So this is, if this is time t, this is t plus 1, and this is t plus 2. So I'll pick up t plus 2 here. Okay, I pick up t plus 2, and I copy that, and I copy it into here, and I paste. And then I rewrite this. This is t plus 2. Okay, t plus 2. So again, when you read your textbook, wherever I have t plus 2 and your textbook says t minus 2, it's okay. Usually when we define lags, we're just saying lag 2, lag 3. And it should be symmetric, whether it's 2 periods forward or 2 periods behind. All right, excellent. So, and then let's do t plus 3. So this is t minus 1, t minus 2. So t minus 3, I'll copy. And then if you have created all these 3 columns, then I'm going to ask you if you can walk ahead of me, go ahead and walk ahead of me, and I'll paste. Okay, and I do this. I'm sorry, I finish this. And I say here, I make it plus. All right. So I have, guys, everyone here, if I want to write the lag here for this one we did xt and xt, what would be my lag here?
0.
Exactly, plus 0. Xt is the same as xt plus 0. Okay, so when we begin to discuss stationarity in a real sense, when I begin to write equations and do proofs, okay, when I say gamma, when I say rho sub 0, that is the covariance between xt and xt plus 0. Okay, and when I say gamma 0, it will be the correlation between xt and xt plus 0. In other words, with itself. All right, so now what I'd like everybody to do is do not do the mean of xt and xt. All right, what in this case, do the mean of xt minus 1 with itself. Do the mean of xt minus 1. Actually, don't do the mean. I don't have too much time, but let's do the covariance and the correlation, and you can fill in the rest later. Okay, so let's do the let's go ahead and do the covariance between xt and xt plus 1. So I'm going to do that now. Data analysis. So I'll do the covariance. And no, I'm going to have to select. So you guys are going to have to work hard at home, doing it to 12 lags. Okay, if you can program it on Excel, go ahead and program. Now, so guys, if you notice, I am selecting one less, right? because I want consistency of the data. Because I'm lagging, the first one of them will not have data. So I select the labels and I do this one. I remove this and I put this here and I say, okay. So it gives me the covariance. Okay. And then I go ahead and do the correlation between xt and xt plus 1. I do it right below it. Anybody angry or frustrated or aggravated? I am, but that's life. William, how are you doing?
I think I'm doing well. I didn't get the same result for covariance between xt and xt plus 1, but I must have just tapped something incorrectly. But
okay, you can totally wipe out those two columns and replace them and do them again. But you don't have to reduce. You can move on to xt and xt plus 2. Okay.
okay.
Yeah. Don't. So I'm going to do up to xt plus 2, and then I'm going to stop, and then I'm going to give us definitions. Okay. And then you guys can finish at home. All right. Where was I? I was at.
So by the way, we're just looking for covariance, right?
Yeah, I just finished covariance. Now I'm doing correlation.
Okay.
Okay. So now I do correlation of. No.
Is there like a quicker way to copy and paste these data analysis like into like so we could do it up to 12?
Wait, you're asking your professor? You guys are supposed to be sharper than your professor.
Yeah, I don't know. It's my first time doing that.
I'm only a professor. Oh my God, you guys are supposed to be smarter than me. So you have to do it and tell me whether you know a simpler way to copy. Those of you who know how to write the scripts, what do you call the programming of Excel?
Once I get my PhD,
VBA.
I'll be smarter than you.
Otherwise,
otherwise, then no.
You're already smarter than me. The professors are dumb. What are you talking about?
Give us 8 years.
No, please. You guys are 10 times smarter than me.
You should be able to automate it with VBA.
Exactly. That's what I was thinking about, VBA.
I don't know the formula exactly in order to kind of like subtract one and kind of copy them over, but I'm sure it's doable.
Yeah, I can program it on VBA, but who cares? I have too many things doing. So you guys go ahead and program and let me know. But if you can do it for the class, do it. And if it works, you can share it with us, please.
Extra credit?
Shut up. Okay, yes, extra credit. I'll buy you only one glass of wine when I see you at Baruch, okay?
What if you're underage?
You shouldn't be in my class if you're underage, unless you're a genius.
Prodigy, got you.
And I probably have to give you permission. Because here, you know, if you're too young, we don't want to tell jokes in your presence. All right, so here, so look at the correlation. I did this earlier and the correlation was negative. Okay, so covariance is negative, so correlation is negative. So let me just do one more, okay? Everybody, I'll just do one more and then that will be it. So just bear with me. Okay, so I'll do covariance. I do covariance again and I do okay. And then I have to select.
Professor, you didn't pick the covariance.
I think I picked ANOVA, right?
Yeah.
Oh my God, sorry. I picked covariance. Thank you. See how I frustrate myself to no end. Where was I? XT plus 2. Okay, so I picked XT plus 2. Thank you. You guys are so sharp-eyed. I would have been asking myself, what the heck did I just do wrong? So now I picked 2 data points less, fewer, because I'm doing 2 likes now. And I do time period here. Okay, now just one more thing, and then I'll give the definitions. And then I'm sure you guys have done xt minus xt plus 10 already while I'm still messing around with 2. Lily? You're done with xt plus 10 already.
Yes.
And your professor is just still messing around with xt plus 10. I feel so bad. Where's my buddy, Ian? Ian, please give me some moral support here. These people are messing with me. Ian probably has done xt plus 12 already. You guys are so smart. All right. So let's do here, and I do here. Okay. Okay. Now, so what have we just done? I have calculated
Why did I get a different answer than you? Mine is negative 0.192559.
yeah, because mine you have more decimal points than me.
No.
Yes, because you have 1, 2, 1, 9, 2, 5, 5, 9. I have 5, 6.
Oh, yeah.
Okay, so what have I done? I have done the I have done expected value of x of t. Okay, that's the mean. I'm just saying it's expectation. And I have done the variance of x of t okay. Sorry. I have done the variance of x of t. And what else did we do? We did the covariance of x of, you know what I want to do? Sorry, let me use the covariance of x of t yeah, semicolon, or rather, let me do how your textbook does it, comma, x of t minus I. T minus I. I am being very careful here to use the notation, okay? That that will not mess me up and therefore mess all of you up, okay? All right. And then having done that, we also did the correlation. By the way, what do we call this kind of covariance and this kind of correlation?
Perfect correlation.
No.
Positive.
No, within itself, within.
Autocorrelation?
Autocovariance and autocorrelation, exactly. Because we're doing the covariance and the correlation within IBM's return. Only IBM. We're not doing IBM and GM, no. Even when we did XT and XT plus 1, it's the same IBM, just lagged one period. Yes? Everybody understands it. So that's what we call autocovariance and autocorrelation within itself. Okay? All right. So what's my mean? My mean is equal to 12.67%. My variance is, for this one, is 406.96. And then the covariance between XT and here, I'll say I equals 2. I equals 1, 2, 3, comma 12. So when you guys do up to 12, you are going to do the covariance. Not XT minus I. In this example, we are doing XT plus I, right? Sorry. Plus. So, excuse me, everybody. For tonight, how many I's, the letter I, how many I's have we done? We have done it for I equal to 0, I equal to 1, and I equal to 2. Okay, so we've done XT, we've done the covariance between XT and XT plus 0. That is really the variance. We have done the covariance between XT and XT plus 1. So I is 1 here. We have done the covariance between XT and XT plus 2. So I is 2 here, okay? Okay.
Shouldn't you start the I from 0 then?
Yes, we already did I from, yes, but I want to distinguish it from variance. So here, this variance is the covariance between XT and XT plus 0. So we already did it here. But separately, I want to write covariance. So covariance 1, 2, 3. But you can write 0, but we already did it for 0.
Wait, why didn't you write it down next to variance? The 406.19904.
Okay, so here. You guys are just tough customers. That's okay. So this is, I'll put it here, I'll paste it. All right, that's okay. You guys are my clients, so I'll do whatever you want. All right, is this okay?
Yeah.
So variance of XT is the same as covariance of XT with XT. So I want to separate XT and XT plus 0 because XT plus 0 is the same XT. So, but I want to have this covariance here where it's not with itself. It's not with itself at the same time. It's with itself at different times. But yes, I can write it from 0, 1, 2, 3, but I want to separate them out. Is that okay? Come on, guys, give me your permission to do it.
Yeah.
Okay. Lily, I need to hear from you.
Yes, I think I'm following.
Okay. Who was not following? Who was asking me questions about, what the heck was I doing earlier? Is everybody following me? Look, I can do the mean, this, and then I will not write down the variance. I'll just write covariance, and I begin from time 0, from I equal to 0, 1, 2, 3. But I just want to separate them because in the definitions, in all the definitions we shall be using in chapter 2, we are going to be writing the mean, the variance, and then all the other covariances. But we understand that the variance is also a covariance with itself at the same time. Yes? Okay, all right. You guys are not answering me. I feel as if I'm on an island talking to myself and talking to the wind, but that's okay. I know you are busy. All right.
I got it. One question I have is really what's the goal here in terms of?
I'm getting to the goal now.
Okay.
So now it's okay. I love it when my students are really very impatient. It means, okay, professor, we got it. Now move on. That's good. I'm boring you. That's fine. So now I'm going to define stationarity now. Okay, guys, I'm going to define stationarity now. And don't worry if you don't get all the definitions, because by goodness, before the end of this semester, you will say, Professor Onoche, please stop. I got it. I was listening I went searching for a good YouTube video, and I'll post it for you all. I'm kind of debating whether to post it now or wait until after Thursday, but I'll make a decision. But that person in the video said that stationarity is basically what time series revolves around. Stationarity. That's how important it is, okay? I mean, some people will say, well, we exaggerate. But I can tell you that most of the concepts that you and I will be learning in this class in time series will center, stationarity will be the center. All the topics will revolve around stationarity. It is such a powerful concept. So that's why I'm taking it really easy to introduce you to it, okay? So bear with me. So definition of stationarity is a time series. What is a time series? This column here. This column of return with its corresponding time is the time series. So if this is IBM's return, this IBM's return from 1937 to 2007 is a time series. So the time series is stationary if this is constant. Okay, the mean is constant. The variance is constant. Covariances are constant at different lags. It sounds simple, but I'm going to explain what I just said. Okay? By the way, what I just described is called weak stationarity. As opposed to strong. In this class, we shall be dealing only with weak stationarity, because strong stationarity is not practical. It's very difficult. All the time series you and I will be coming across, the best they can be is weak stationarity. Okay, strong stationarity is too theoretical, is too ideal.
Professor?
Yes, ma'am.
What is the main difference between weak and strong? They're like mean variance and covariance are not constant.
Okay, I just love all of you in my class because you all are so curious. That's excellent, Nadia. All right. So what have we just described for weak stationarity is the constancy of the first two moments, yes?
Yeah.
Yes.
Okay, so the first moment is the mean, the second moment is the variance. So the first two moments must be constant. And this is really, the covariance is, you can think of the covariance as the joint distribution, because it's covariance is the relationship between two things separated in time. It's IBM's return in time t with IBM's return in time t plus 1. relationship between two things separated in time. But what is the, here, excuse me, for this one here, what is the separation in time for this one here? What is the separation?
One lag.
1. What is the separation here is 2. Okay, so IBM's return in time t and IBM's return in time t plus 1, they are two distributions. So the covariance between them is what we call the joint, it's a moment for the joint distribution. But it's the second moment. So here, essentially, the mean and the variance, the first two moments are constant for weak stationarity, okay? Nadia?
Yes.
Okay. Now, let me describe strong stationarity. How many moments did I introduce us to so far?
4.
2.
4. No,
4 in
I
total.
mean, this class 4. But how many moments do you think there are in statistics? Yeah, hundreds.
Infinite?
Yeah, in fact, as many moments as you have data for, -1. So strong stationarity needs all the moments to be constant.
So for example, is this stationarity that we're looking at this data right here, or no, because all the covariances are different for each time, like lag.
Okay, I haven't gotten there yet.
Okay.
Okay, now I will tell you, okay, to answer your question is, there are many, you see, you remember how we performed the Jacques-Berat test for normal distribution, right? Later, maybe in a week or so, I shall begin to discuss with us, actually maybe in 2 weeks, the different tests that we use to test, for example, this time series to see if it's stationary or not. There are many different tests. Okay, the most popular is the one we call ADF, augmented Dickey-Fuller. But don't worry about it for now. I shall give you a list of maybe 5 or 6 different tests we use. But the most popular one is the one called DF. It's called ADF, augmented Dickey-Fuller. But I need to build up something, building blocks before we get there, okay?
Got it. Cool,
Right.
thanks.
But for now, I just cannot eyeball this data and say it is stationary or not. I can't say that for now. Until I can guess, but so Nadia, strong stationarity requires the mean to be constant, the variance to be constant, the skewness to be constant, the kurtosis to be constant, the 5th moment to be constant, the 6th moment to be constant, 7th moment. Can I go on?
Many more.
Okay.
Yeah, no, many more. Yeah, I understood. Thank you.
Okay. And in practice, our data can never be this. So in practice, everywhere in economics and finance and biology and everything, we only talk about weak stationarity. Okay? All right. So weak stationarity, but anytime I say stationarity in this class, I mean weak stationarity. I'm not messing with strong. Okay. So weak stationarity requires for the mean to be constant and the variance to be constant, and the covariance at each lag to be constant, but the covariance between xt, the covariance at different lags don't have to be the same. They don't have to be equal. Let me say that again. The covariance between xt and xt plus 1 is 411.15, yes?
Yes.
Okay. The covariance between xt and xt plus 2 is 407.9874. They are different. Okay? But what does stationarity mean? Now, maybe on Thursday, I will plot a graph of this series, or I will bring more standard graphs to show you. Now, everybody come with me here to this point, okay? Is everybody looking at this point? I'm in 1937, right? If I begin from 1937 and I begin to lag t plus 1, from 1937, t plus 1 is 1938, right? From 1938, t plus 1 is 1939. Are you with me so far? Okay. If it doesn't matter where I begin, everybody please look. This is quite important. If I begin here, if I begin in 1937, t plus 1 is this. From here, t plus 1 is this. From here, t point 1 plus 1 is this. If I find the correlation between all these this adjacent t plus 1s, and I skip forward, and I begin in 1950, and I do t plus 1, and I 2 plus 1, I 2 plus, and I find the covariance. And all these t plus 1 covariances when I started here, and this t plus 1 covariances when I began here. It doesn't matter where you begin in the time series, the covariance between t and t plus 1 is the same.
Is that the concept of ergodicity?
Let's not go to ergodicity yet. I just love this class. You guys are just way ahead of me. But for today, I want to stop in weak and strong stationarity. Next class, I will talk about, I'll just mention ergodicity, but we don't need it in this class, but I'll mention it now that you ask. So, and again, let me go back. If I begin in 1937, what is t plus 2? It's 1939. What is t plus 2? 1941. But it doesn't matter if I begin in 1937 and covariance between xt, 1937, and t plus 2 going forward. Or if I begin in 1954 and so my xt is 1954, t plus 2 is 56, t plus 2 is 50. If I do correlation between one time period and it's two lags, it doesn't matter where I begin in this time series, the correlation, it doesn't matter where I begin, as long as it's one lag, the covariance will be this. It doesn't matter where in the time series I begin. Or it doesn't matter where in the time series I begin, the two lags, covariance between where I begin and two lags subsequently will be the same, constant. So the only difference between the covariance, the only difference is the number of lag. It's not where I started from. It's not where point x of t. It's not where that t is. Are you with me? It doesn't matter where I begin.
Yeah, I got it.
Okay, now everybody do this. Everybody do this. When you finish correlation up to t plus 12, okay, everybody please watch this. Then I need for you to plot the graph. On the y-axis, you have the correlations. So in this case here, the correlation, this one, I'm sorry, the correlation, what is the correlation at lag 0 for anyone? What is the correlation at
1?
It's 1. So you plot 1 on the x-axis and 0, I'm sorry, 1 on the y-axis and 0 on the x-axis. What is the correlation at lag 1?
Negative 0.01.
Okay, so at lag 1, so on the x-axis you plot lags. So at lag 1, the correlation is negative this. At lag 2, what is the correlation? This. So lag 1, so you will have lag 1, so lag 1, okay, on the x-axis, and then lag 2 on the x-axis, and then, I'm sorry, and then lag 3 on the x-axis, and then on the, so, and then lag 0 here. So put lag 0 here, lag 0 here. So at lag 0 on the y-axis, the correlation is 1, you plot it. At lag 1 on the y-axis, the correlation is negative. At lag 2 on the y-axis, the correlation is negative. So plot the correlation, the correlations on the y-axis and the lags on the x-axis. Are you with me so far? And plot that graph. That is what is called the autocorrelation function, ACF. Okay? All right. Lily, you're talking to me, but you're muted, but I know you're saying yes. Don't worry about it.
Yeah, sorry.
Yes. So does everybody understand the homework?
Yep.
All right, so I'm going to stop sharing now, and I'm going to stop recording.
The recording has stopped.
Okay, guys, I have to apologize for just, but this is the level of detail I want us to do. Okay, guys, this is the level of detail I want us to do, so that when we begin to talk about stationarity and ACF, autocorrelation function, and partial autocorrelation function, and portmanteau tests, and all of that, you will understand where I'm coming from, okay? All right. Whew. I was debating, should I do this in class, but I think it's worth it. Please, everybody, I know this will drive you crazy, but please, I beg you, try to take it up to 12 lags. You don't have to do everything today. You can just do it if you today, if you tomorrow, and if you on Thursday, and then come show me your graph and your results on Thursday. But the graph you plot is what we call the ACF, autocorrelation function. And it's going to be quite important, okay? And those of you who are curious, why the heck are we so concerned about whether a series is stationary? Because as you will see, depending on the definition of stationarity we have, if the autocorrelations are constant, then that means today's, if the correlations are constant at different lags, that means if I know IBM's price today, guess what I can do? And I know that the series, IBM series, is stationary, then I can predict IBM's price tomorrow if I know the correlation, right? But what does efficient market hypothesis tell us from investment? Anybody remember?
The strong market theory suggests that the market is not predictable.
It's not predictable. But if through through our search of stationarity, we can figure out that the market is predictable, and therefore we can fit in an equation that we can use to do the prediction, we can make money theoretically, and therefore we shall question our concept of efficient market hypothesis. So what you and I are always doing, especially in the field of investment, we are trying to figure out if the market is inefficient, it's not efficient. And if the market is not efficient, efficient market hypothesis does not hold, even if it's for a brief period of time. That means the market prices are predictable. That means we can forecast the prices. And if you can forecast the prices, you can make money. But again, don't forget that in real life, you have to figure in the transactions cost, the commissions and the margins and everything, yes? Okay, so that's one of the implications of our search for stationarity, and we shall do more, a lot more in this class, okay?
Professor,
guys?
are you going to do a live demo of you trading stocks and forecasting?
No, I won't do that because I don't want you to see my trading strategy and go replicate it and make money. Yeah, no. I may give you an exercise. I may give you an exercise to to just try some strategies, but I have to design it so that it will not be too tedious for you. But that's where we're headed. That's one reason. And later, I'm going to introduce a concept called co-integration and so on and so forth. Okay, so what do you mean? I use them all. No, because as again, that's a great question. As you'll see, just like for testing whether a series is stationary, we are going to be applying several different tests because one test alone will not have, some of them don't have enough power. I actually don't like IBM. It's just the first thing that comes to my mouth. All right, guys. Hey, everybody, you good people. I hope today was a little bit manageable, but please run through this exercise yourself up to like 12. I'm sorry if it's tedious, sorry. But when you finish, plot the autocovariance function and also the autocorrelation function. Yes, I know it's tedious, and then bring it to class, okay? All right. Good night, good people. Yeah.
Thank you.
Bye, Nadia. Thank you for your questions, okay?